Right, when I'm on motorbike tours, going around the jungles of Thailand, one of the first questions people ask me when I stop for a coffee or something to eat, if I cube one of the complex cubed roots of unity, will it really equal 1? And that's what I'm here to address now. In the last video, I went over how we can derive the 3 complex roots of the cubed root of 1. And in this video, I'm just going to show you that if I cube one of those roots or raise it to the power 3, it does indeed equal 1. Now here we go. One of the roots was -1/2 plus root 3 over 2i. That was one of the complex roots, one of the complex cubed roots of 1. So if I cube this, I multiply it by itself 3 times, I should end up with 1. So all of that gobbledygook, all of that dog's dinner, after we manipulate it and expand the brackets, we should end up with 1. So let's see if that is indeed what happens. So the first thing I'm going to do is expand the first two brackets here, using the standard FOIL method. Alright, first, outside, inside, last. So let's get on with it. -1/2 times -1/2 is 1/4. Yeah, that's the first one. Then outside, -1/2 times root 3 over 2. That's going to be minus root 3 over 4i. Then inside, that's going to be the same, minus root 3 over 4i. Then the 4i times I is I squared. And that still have to multiply by this third bracket. But first I'm going to have to simplify this a bit. Now I squared is -1, and we can add these two terms together. So I'm going to end up with 1/4 minus, well, there's 2 lots of this stuff, so that's 2 root 3 over 4i. And if that's -1, that's going to become -3/4. And it's still times this -1/2 times root 3 over 2i. Still in that. That's still the same, this one. I'm just dealing with this one first. So 1/4 minus 3/4, well, that's -1/2. They're just 2 constant terms, and I've got this term here, which 2 over 4 is 1/2, so it's minus root 3 over 2i. Okay, and now I can expand these ones, but you'll notice they're conjugates. These are complex conjugates. They're exactly the same except them signs. So let's expand these last 2 brackets and see what we get. -1/2 times -1/2 is 1/4, positive 1/4. And then I've got -1/2 times this. That's going to give me minus root 3 over 4i. And then I've got this one times this one. It's going to be plus root 3 over 4i. And then the last 2 terms, it's going to give me minus 3 over 4i squared. Now I can see this term and this term cancel out. And that I squared becomes a -1. So I'm going to have 1/4, and that's going to be, turn this sign into a plus 3/4, and the whole thing equals 1. So that's incredible. If I cube one of the cubed roots of 1, one of the complex roots with all this gobbledygook, if I work it all out, it all boils down to 1. It's absolutely incredible. Now I believe one of the reasons we are here at all, one of the reasons we exist, is as apertures for the universe to see itself, for us to look in awe and wonder at things in the universe. And for me, mathematics provides a bit of that. I look at all that rubbish up there and it all eloquently boils down to 1. It's absolutely incredible. It inspires a lot of awe and wonder in me, and it's one of the reasons I love my maths teaching job. So that's it. Stay curious, kids, and thanks for watching. See you later.